The first part is the value of 10a is always less than 1. So what do you think about 10? Is this statement right? Will our 10a be always less than 1? Let's draw a diagram and visualize 10a. Like this is one of the case. Here we go. I've drawn a right angle triangle. Okay. And this angle is 90 degree. Let's say this is B and here is A. All right, so this third vertex C. What do you see? What would be 10A? Oh, from SOHCAHTOA, our 10 was, what was 10 theta or 10A in this case? 10A is opposite by adjacent. So BC divided by AB. For angle A, opposite is BC and adjacent is AB. Okay. Well, so BC by AB in this case, we can see in the diagram itself, the BC looks much longer than AB. So the fraction BC by AC is going to be bigger than 1. That's what we will give our justification as, right? So what we can say, the part 1 is false, okay? Because you can say 10 theta can be greater than 1. You can say 10 theta can be greater than 1. Or you can give example like justification like 10 theta is greater than 1 if the side opposite to theta, which is A in this case, is bigger than the adjacent side. Okay, so this is the first case is done. Second is sec A is 12 by 5 for some angle A. Look, to justify whether sec A can be 12 by 5 or not, what you can do is you can first find cos A, you know, and we know that the cos A is the reciprocal of sec. Sec is the reciprocal of cos and cos is reciprocal of sec. Cos A is 1 by sec A. This means we can say our cos A would be reciprocal of this number 12 by 5, which is 5 by 12. It looks like this is fine because how do we define cos? Cos of A is adjacent side divided by hypotenuse, which looks like the numerator is smaller than denominator. So we can actually make this kind of right angle triangle where hypotenuse is 12 and adjacent side is 5. In that case, our sec A would be 12 by 5. For the second one, we can say, we will write it like this. The second one, we will say true. Second one is true. And because sec A is always greater than 1. Sec A is, sec A can be greater than 1. We can write like that. Sec A can be greater than 1. Our sin A and cos A cannot be greater than 1, but sec A can be greater than 1. Now the next one is cos A is abbreviation used for cosecant of angle A. We know cos A is the abbreviation used for cosine of A, right? Look, the abbreviation, the first ratio we said sine and we used abbreviation for it as sine. Okay, sine of theta, sine theta. The second one was cosine, and the abbreviation used for cosine was cos theta. Yes, so that means the third one, what we can say about the third one, cos is abbreviation for, yeah, it's false. This is false. And the justification, you can say cos A is abbreviation for cosine of A. Cosine of A. So the third is also done. And the last one, no, it's the fourth one. It says cot A is the product of cot and A. We know this is not, right? So this one is false. And why? Because cot A is actually the ratio of the side, which is adjacent side to opposite side of the angle A in a triangle ABC, right? In a right angle triangle ABC. So you can say that cot A is ratio of sides adjacent to angle A, adjacent to angle A to side opposite to angle A. You can actually show a right angle triangle and where you can show what the cot A means, right? You can actually, in justification, you can draw this diagram also. And if this is angle A and let's say this is B and C, so you can further write that cot is not the product of cot and A, but the cot A is actually AB, which is adjacent side, divided by BC. So this is justified that cot is not a product of cot and A. Next one is sine theta is 4/3. We know our sine theta, which is opposite side divided by hypotenuse, right? Hypotenuse. So this can never be more than one. So that means the last statement sine theta is 4/3 is false. So for fourth one, we will say false. We will first write false and then we will give region. And the region is sine theta is always less than. Sine theta is never more than 1. Never, or sine theta can never be more than 1. All right. Sine theta can never be more than 1. Why we are saying sine theta can never be more than 1? Again, you consider that right angle triangle where you have any angle theta. Let's say this angle is theta. So when we say sine for this, it will be this side over hypotenuse. So the hypotenuse is the longest side. For that region, sine theta would be less than 1. So finally, to sum up, we can say the first statement is false. The second one is true. The third one is false. The fourth one is false again. And the last one is also false.